So when I factor, I always go through these steps in my mind. Okay? First one, look for what's common. I call it a greatest common factor, GCF. All right? It could have 2, 3, 4, 10 terms in it. Okay? Look and see if there's something common to all the terms. All right? The second thing I look for is called a difference of squares. It's got 2 terms, is all it's got. It's a binomial. And they're both perfect squares, meaning 1s or 9s or 16s or 64s or 100, some number that's a perfect square, or any variable to an even power is a perfect square. So second, fourth, sixth, eighth power, those are perfect square variables. But it must have subtraction between the two in order to be able to factor it as a difference of squares. The third thing I look for is another 2-term polynomial, which is a binomial again. It's called a sum or difference of cubes. In this one, there's 2 terms that are both perfect cubes. The perfect cubes are like 1 to the third, which is 1, so 1 is a perfect cube. 2 to the third is 8, so 8 is a perfect cube. 3 to the third is 27, so 27 is over there. Okay, if you're not sure if it's a perfect cube, go to your calculator and hit math, and number 4 there is cube root. So hit 4, let's say 64 was a number in the problem. You were checking to see if it was a perfect cube. Is it? Yeah. You get a whole number there like that. 4 cubed is 64. So 4 to the third. That's the third power. So if it's a number like that, and if it's got variables, it has to have a power of 3 or 6 or 9 or 12. Multiples of 3. Okay, they can be addition or subtraction. So if it's not one of those 3 things that I can do, then I look for a special trinomial, 3-term. It's called a trinomial square, or sometimes they call it a perfect square trinomial. And when I look to see if it's one of those, I look at the first and third term. The very first one, the very last one. And if they're both positive perfect squares, it could be one of those. So then I do something I call the 1, 2, 3 test. And I'll show you that here in a few minutes when we get to one of those. The next thing, if it's not one of those 4, then I look, if it's got 3 terms, I look at a regular trinomial. There's a certain way to do that. When I look at trinomials, the number in front of the x squared, I always call the a value. The number in front of the x, I call the b value. And the number on the end, the one without the variable usually. Sometimes it has a variable, but most of the time, that number is the c value. Okay? And then there's a certain way to do those. And then if it's got 4 terms, we'll just have 4-term grouping problems. We'll group it, and I'll show you how to do those. Okay, so this should be a review. You did it as freshmen, you did it as juniors, you're doing it again as seniors. Okay? But that's what I always go through in my head when I do a factoring problem. Okay, so let's just practice some. I'll show you how to do some, and then we'll get to your assignment. So directions are factor. Always factor completely. That's what it says at the bottom here. I didn't do that, but factoring completely means sometimes you got to factor again. It's like a factor sheet. So sometimes you can do another step. So don't always think one step and you're done. Anyway, this one. I always think, is there a GCF? Is there something common to both terms? Or what goes into both terms? Is there a number or a variable? 2 and x, right? So, we take out the GCF, and we make a set of parentheses. If there's two terms to start with, my parentheses will have 2 terms. If there's 3 terms to start with, and I pull out a GCF, then my parentheses will have 3 terms. Okay? Got to keep up. So then I take this GCF and I divide it into those This is what I'm doing. I don't usually write it out like this, but this is what I'm doing in my head. So what's 10x to the third divided by 2x? 5x squared, right? We should all be able to do that. Division problem. And then what's 6x divided by 2x? 3. Okay? And you're finished. This isn't, it's two terms, but they're not both perfect squares, they're not both perfect cubes, so it's not one of those binomial type, number 2 and 3 on our list. And if you want to check, if you distribute, you should get what you started with. Questions? Okay, second one now. Is there a GCF? Nick, is there a GCF there?
3x and 1.
3xy squared, yeah. Both of these have a y squared, right? Sometimes you'll get an exponent with one of your variables for a GCF. That's okay. Okay. How many terms are going to be in my parentheses? 2. So make sure you make room for 2. So negative 6x squared y squared divided by positive 3xy squared is negative 2x. 3xy squared divided by 3xy squared is 1. Sometimes I get kids, if that happens, they forget to put the 1. They think, well, it cancels out, so there's nothing there. Well, they do cancel out, but there's still a 1 there. So don't forget to write the 1. Right, Hassan? Questions on those? 2 examples to get started. So always look for a difference of squares to start every factoring problem. I'm sorry, I said that wrong. Always look for a GCF to start the factoring problem. Okay? All right. These are trinomials, 3 terms. Okay? I should have went in order of the list, but that's okay. So, what's my A value in this problem? Well, the number in front of the x squared. 1. What's the B value? 7. What's the C value? Negative 18. You with me on that? It's the numbers in front of the variables. If it doesn't have a variable, it's just that number. Okay? But it's got to make sure it's in that order. Most of the time, they write it in the right order. If they don't, go from biggest exponent to smallest. So, it's got 3 terms, so it's not number 2 or 3. It's not a difference of squares, some are difference of cubes. To be number 4, that special trinomial, this has to be positive and a perfect square. It's not positive and it's not a perfect square. So it's number 5, a regular trinomial. When A is 1 like this, it's really easy. You just make 2 sets of parentheses. Okay? And whatever this variable is, squared, it's just that variable. X times x is x squared, right? Now, what happens sometimes, you guys they'll put a 4 here, x to the 4th, and an x squared there. And you guys say, oh, what do I do? Just cut it in half. If that was x to the 4th, these would be x squared and x squared. That's all. And then, when A is 1, just worry about the negative 18, the C value. Okay? And I think in my head, think about all the factors of negative 18. So we could have those 2 factors, or these 2. All right. So those are all the possible factors. When I multiply, I'll get negative 18. Okay? Now, in my head, I add all of these. That's a 19, that's a negative 19. That's a positive 7, that's a negative 7. That's a negative 3, that's a positive 3. And I look over here at the B value. So So I want the pair that gives me that B value. All right? So I want that pair, right? If I add those, I get positive 7, right? So I just put negative 2, positive 9, it's factored. You guys remember that type question? Those are easy. Really easy when A is 1. Just like this one. A is 1, what's B? Negative 9, what's C? 14, okay? Another thing I wanted to tell you, whenever C is negative, you're always going to have a negative and a positive. Whenever C is positive, you're going to have, in this case, 2 negatives. If that's a positive, you have 2 positives. That always be true. When the C is positive, they're both whatever is in front of the B number. All right? So this one, again, A is 1, so it's X times X. Since C is positive, they're both B, which is minus, so I'm going to make them both minus. And then I think of factors of 14. 1 and 14, I guess they have to be minus, negative 2 and negative 7. Which pair works? The 2 and the 7, right? So minus 2, minus 7, you're all done. That's easy. That's simple. You can do it. Okay? Questions on regular trinomial when A is 1? Pretty quick and easy. You guys are really good at this. You'll be really good at this by Friday's quiz, too. Now, this one's a little bit tougher. Why? Because A is 6, right? So here's what I do when A is not 1, when it's 2 or bigger. I take the A and I multiply it by the C. What's 6 times 4? 24. Okay, now, when you were first taught this by your freshman algebra teacher, maybe 8th grade, you might have been taught like a guess and check method, like find the factors of 6x squared and 4, that when you get them in the right combination, it gives you negative 11 in the middle when you FOIL it. And if you're good at that, you can still do it that way. The way I want to show you here, you don't have to guess and check. Once you go through it, it'll give you the answer. Okay? That's why I like it. It's not guessing and checking. So remember, since that's a plus, they're both minus. So it'd be negative 1 and negative 24, negative 2, negative 12, negative 3, negative 8, negative 4, negative 6. Which one do I want? This one. Line 11, right? You guys with me? Okay, so this is the pair I want. All right? So I go rewrite this problem. The first term doesn't change, the last term doesn't change. It's this middle one I change. I rewrite the negative 11x as negative 3x minus 8x. So I turn it into a 4-problem or 4-term problem. Okay? Which is called a grouping problem. So I just rewrite it. And then I do grouping. Okay? When you group, you just group first 2, last 2. Now, when you do the last 2, group. If there's a minus sign or a negative sign in front of that third term, put it inside the group. And then just put a plus sign between your 2 groups. If it's already plus, if that was a plus 8x, I would have just put my left side, my left parenthesis, between the plus sign and the number, and the 8 if it was plus 8. Okay? And I'll tell you why in a second. All right, then we go back to the beginning. What do we always do in these problems? What's the first thing we do, Kenny? Number 1 on our list. So, what's the GCF between those 2? 3. 3x. What's 6x squared divided by 3x? What's negative 3x divided by 3x? Okay? When this is negative, always pull out that negative sign, even if that's not. If that's a negative, pull the negative sign out. What is the GCF between 8x and 4? 4. Oops, I want that to be red, just so you can see. Then I divide again. Negative 8x divided by negative 4 is positive 2x. Positive 4 divided by negative 4 is negative 1. If I didn't pull out the negative, I put plus 4, then I would have got negative 2x plus 1. Is negative 2x plus 1 the same as 2x minus 1? No. I want these to be the same. See how they're both 2x minus 1? So whenever you see that minus sign there, put it inside and then pull out the negative sign here. Okay? Things work out for you. If these aren't the same after you do that, then you can't factor. Okay, but check your work if that happens. Just recheck, make sure you didn't make a mistake. But if you check and you didn't make a mistake, and these are not the same, then you're done, just say not factorable. But if they are the same like this, then that's one of my factors. Even though it shows up twice, you don't have to write it twice, you just write it once. And then the other factor are these GCFs you pull out, 3x minus 4. If I FOIL this, I'll get that. Okay, so that took a little bit more work. What happens is you guys get good at doing this, and then when you see one like this, you do that still. Do you need to do what I just did with these two? You don't have to. So save yourself some time. When A is 1, just look at C and do it. When you get a 2 or bigger here, then you got to do what I just did. Questions? Start to remember that from before? Hopefully. Okay, good. Difference of squares, number 2 on our list. No GCF. Nothing goes into either one of those. But they're both perfect squares and there's a minus between them. So that means there's a certain way to factor it. When you recognize it's one of these, you go ahead right away and make 2 sets of parentheses. And then you just take square roots. What's the square root of 49x squared? 7x. That goes in the front of both. What's the square root of 144? 12. That goes in the back of both. And then one's addition and one's subtraction. Doesn't matter which one's which. Just one of each. If I FOIL those, I'll get the 49x squared minus 144. Because the outside is negative 84x, the inside is positive 84x, and what happens to it? What's a negative 84x plus 84x? Nothing, right? 0? It's not there. Okay. Coming back to you. What do I got to do first for this next one? What do we always do first? GCF. Is there a GCF? 2, right? So pull the 2 out. You get x squared minus 9. What's that called? What's it called? Difference of squares, right? X squared and 9 are both perfect squares, and there's a minus between them. So you make 2 sets of parentheses. Mr. Myers, what's in the front of both? All right. The square root of x squared is x in the front, square root of 9 is 3 in the back, one's a minus, one's a plus. That easy. Once you recognize it. Questions? Some of you are struggling. Come on. Stay with me. No questions? Okay. This is that special one, number 4 on the list, perfect square trinomial. Okay? Is there a GCF? Always remember to do that. I say that all the time and we always forget. Michael, don't you forget this year. You never forgot last year though either, did you? All right, there's no GCF in this one. Okay? Number 4, this type, you look at the first and the third term and you see if they're positive, perfect squares. Are they? 16, 25R, m squared and n squared r, and they're both positive? Yeah, it's one of those. Positive perfect squares. So, here's the 1, 2, 3 test I was talking about. Hasso, what's the square root of 16m squared? M, don't forget about the variable. Okay? Mr. Robbins, what's the square root of 25n squared?
5.
Good. So that's what we do for 1 and 2. With our 1, 2, 3 test. We take the square root of the first term and the square root of the last term because they're positive perfect squares. Number 3 is just multiplying the two answers together. What's 4m times 5n? 20mn. Okay? What you ask yourself, is this half of letter B, or as I call the B value? That's the question I asked. And somebody just said yes. 20 is half of 40, right? If that's true, then it's one of those special trinomials. So that's a quick test. And I like to do the test because the answer to number 1 and 2 is part of the answer to the problem. In these, all you have to do is make one set of parentheses. And number 1 goes in the front that you got, and number 2 that you got goes in the back. Whatever the sign of B is, goes in between them, and then you square it. It's actually, there's 2, 4m minus 5n. If you don't recognize it's one of those, that's okay. You can do it as a regular trinomial. If I multiply 16 times 25, I get 400. The factors of 400 that add up to 40 or 20 times 20. If I rewrite this as 16m squared minus 20mn minus 20mn plus 25m squared and group it, when I'm done, I'll get 2 of these. So you'll still get it if you don't recognize it's one of those. So if you don't even want to learn this way and just want to do the regular trinomial way, you'll still get the right answer. But this is just a little quicker if you recognize what it is. Make sense? So what do I got to do first for this one? Chris? Yeah, is there? Yeah, 3. So then we get 4x squared plus 12x plus 9. 3 terms, are those both positive perfect squares? They are, aren't they? So number 1, to my 1, 2, 3 test, because it could be one of these, is the square root of that, which is 2x. Number 2, the square root of 9. Number 3, you multiply those. 2x times 3 is 6x. Is that half of the middle? Yeah, so it is one of them. So you just bring your 3 down. You know you're going to square it. Number 1 in the front, number 2 in the back. And then the plus, because that's what's in front of the B. That's those. Again, you can still do those without this quicker one. You can do it this way if you want. It'll still work. Okay? Questions? Am I going too fast? Okay. 2 more types. We already did the second type. I was going to show you, basically. But here's the cube one. Number 3 on our list. 2 terms, both perfect cubes. Could be minus or plus. perfect cubes are something to the third power. 1 to the third is 1. 2 to the third is 8. So 8's a perfect cube. 3 to the third is 27. So 27 is a perfect cube. 8's a perfect cube. 4 to the third is 64. Okay? If you're not sure, go to your calculator, hit math. Number 4 is the cube root. So hit 4, and let's say you're looking at a 64. Checking that. Would you say yes, it's a perfect cube? You would, wouldn't you? Okay. I think I already showed you that today, didn't I? So, when you do one of these, when you recognize it's one of these, you make a set of parentheses that will hold 2 terms, a binomial, and the second set of parentheses holds a trinomial, 3 terms. So make it a little bit further apart. And these are really easy once you recognize what they are. Cube root of this first term, cube root of a cubed is 2a, goes in the front. Cube root of b cubed is b, it goes in the back of that. And this symbol there, plus, matches that. It'll be the same. Okay? This cube root. That's how you get the binomial. You use the binomial to write your trinomial. You take the first term and square it. What's 2a times 2a? 4a squared. You take the 2 answers, both of them, just multiply them. What's 2a times b? 2ab. If that's plus, then this one is opposite day. They're always opposite. The middle term and this one are always opposite. The third term's always plus, no matter what, and then you square that one. What's b squared? B times b, b squared, right? So once you recognize what it is, it's pretty easy to write it out. Okay, this is also one. 27 is a perfect cube. The cube root of 27 is 3. That's symbol. Cube root of y cubed is 1. Real easy to get that. First term, square it. 3 times 3, 9. That's a minus, so the middle is a plus. Then multiply. 3 times y, 3y. This is always addition. And you square that. Y times 1, y squared, you're done. Simple. Okay? Sleeve, keep sitting there. And the last type is grouping, which I showed you in that one way. But it's got 4 terms, grouping. So we group first 2, last 2. Just like that one we turned into a grouping problem. That's a negative, so put it inside the group. Put addition between them. Now, what do I pull out of each group? G, C, F, right? So what's the GCF of the first group? What else? 3, good. 6y cubed divided by 3y squared is 2y. Negative 21y squared divided by 3y squared is negative 7. Since there's a minus there, pull it out. What goes into 4y and 14? 2. Negative 4y divided by negative 2 is positive 2y. 14 divided by negative 2 is negative 7. So Garrett, what's my answer? Now that it looks like it's supposed to be? These are the same? That's what I want, right? So that's one of my factors, okay? What's my other factor? What haven't I written down that you see up there above it?
3y squared minus 2.
Good. That's right. That will be my answer then. Okay? So these have to be the same for me to finish it up. But most of the time they will. If they aren't, then you just say it can't be done, not factorable. Liam, any questions? You got it, huh? Easy stuff, right? AJ? Okay, you guys are struggling. Tuesday afternoon, after lunch, it's kind of warm. You had a good lunch. Got the naps coming on. Right through it. The golden tones of Mr. Madigan. Right. Okay. There's your assignment. Going by fives. 5, 10, 15, 20. Skip 25, 30, 35, 40, 45, 50. All the way to 80. It'll be all those types that we just went over. Okay? Again, you guys have done a good job so far. For the most part, there's a few of you that need to kick it in gear because you started out with not a very good quiz grade. So kind of put yourself in a bit of a hole. So pull yourself out this week. If you need help, don't hesitate to ask.